Hello, my dear ones. Welcome again to my YouTube channel. Today, I will give you about the hybridization SP2 and SP. Perhaps my previous classes you have attended and you are benefited. Your comments I have gone through and replied. But even though if you have any problem, you kindly contact me and watch video till end, because this is very important lecture about the hybridization. If you are new in my channel, please subscribe and share so that my latest video will reach you first. So let us start SP2 hybridization. SP2 hybridization. As you know, hybridization is a process. Hybridization is a process of mixing of unequal energy orbitals and formation of same number and same energy level of orbitals. I have told you earlier, this is the hybridization. Again, right? Hybridization is a process of mixing and reformation of orbitals of equal energy levels and same numbers. In sp2 hybridization, 1s and 2p orbitals go under hybridization. Hybridization is a theoretical process. It is only theoretical process by which we understand the structure and shape of the molecule. So in sp2 hybridization, 1s and 2p orbitals goes under hybridization and formed 3 numbers of equal energy level orbitals called sp3 hybrid orbitals. Let us see, for example, in C2H4, if we see in C2H4, ethene, this is called ethene. So here carbon, this is ground state, 1s, 2s. As you have seen previously, the electrons are filled as per rule of Apau principle. This is increasing level of orbitals. This is 2p. This is px about py and pz. So this is the ground state. This is called the ground state. In ground state, carbon have 6 electron, 1 in 2s, 2 into 2s, and 1 in px and py, that is 2p2. So before bond formation, there is a process that is called excited state. So this electron is moved in this state, so the structure become in this way. This electron moved here, and the single 4 electron. This is 2s. This is 1s. So now these 4 single electrons are available to form the bond with other atoms. But if at this state there is a bonding, then bond length and bond energy of all these bonds are different. This bond have lower energy than this. Therefore, this state is called excited state. Before bond formation, the hybridization take place here. This one, equal energy levels will form 1s and 2p. Near the hybridization will go with the nearest orbitals which have least difference of energy. Pz is higher energy than py, and py have higher energy than px. So the px and py has very near to the 2x energy. So this will form like this. SP3 hybridization. Here 1s and 2p go, so form SP2 hybridized orbit, SP2, and this is the single, and one unhybrid orbit. Pz is one hybrid orbit. So this is the hybridized orbit. Hybridization take place. This is called hybrid. So now this carbon goes under hybridization, in which 1s and 2p orbital form sp2 orbits of same energy. So this is called the sp2 hybridization. Now in C2H2, hydrogen has 1s1, that is like this, single bond. So this will make the bond with sp2. So this is hydrogen, and this form with carbon or any other. This is hydrogen. Then this type of bond is formed. So we will see the structure of C2H2 if we sketch in the form of orbital. Carbon, you have seen carbon has 3 sp2 hybrid orbital. One this, second is this, third is this. And this carbon has 3 sp2 hybrid orbital, and one pz is unhybrid orbital. This is pz orbit, unhybrid. Similarly here pz is the unhybrid orbit. So this is sp2 hybrid, this is sp2 hybrid, this is sp2 hybrid orbital, this is sp2 hybrid orbital, this one is also sp2 of second carbon, this is sp2 hybrid, and this is pz is unhybrid orbit, unhybrid orbit. This also is unhybrid orbital. So if we see in C2H4 both carbon are sp2 hybrid and single electron, here single, here single, here single, and pz also have one single electron, like this way. Second carbon will also have one electron, one in pz, one in sp2. There are 3 hybrid orbit and 1 unhybrid orbit. Now hydrogen, 4 hydrogen is spherical, 1s is spherical orbit, have single electron. So it will combine with this carbon like this. This is hydrogen and form pair of electron. This is hydrogen. Similarly here, this is hydrogen and make the octet complete. 1s electron complete. So similarly here 1s bonding like this. So now you see this is hydrogen, this is hydrogen, this is hydrogen. So 2C and 4 carbon make such type of bond. But here unhybrid orbital has single electron. This is paired. This orbital is completed. One orbital have 2 electron, one in opposite rotation. So here carbon make this electron, but pz are unhybrid, so this will unhybrid orbital form separate bond. This is called pi bond. This is called pi bond. Unhybrid hybrid orbit for pi bond and hybrid orbital form sigma bond. You write down here the hybrid orbital formed sigma bond and unhybrid orbital of both orbitals of both carbon make pi bonds. So this is the pi bond, unhybrid. Now we see the structure of this. This is triangular planar. Shape कैसी होगी? Triangular planar. In one plane, this is triangular planar. Shape of sp2 hybrid orbitals. This is triangular planar. This molecule sp2 hybrid will be triangular planar. And here write down again S character 33%, P character 66%. You understood SP3 just percent of. So S character 33, P character 66%. The shape will be triangular planar and bond angle will be 120 degree. This is 120 degree. This is 120 degree. So this is 120 degree between the hybrid orbitals, 120 degree. So bond angle will be 120. So I think you understood what is hybrid sp2 hybridization. In sp2 hybridization, 1s and 2p orbitals of different energy levels undergo hybridization, form sp3 orbitals, same number, same energy orbitals, and form such type of bonds. Hybrid orbitals form sigma bond, unhybrid orbitals are form pi bonds. The shape of sp2 hybrid is triangular planar. Bond angle between the hybrid orbitals is 120. S character 33%. And one thing you must know, as S character increased, acidic nature of the increase. I have told you earlier, in sp3 S character 33%, sp2 S character ये 25% था, this is 33%. So this is increasing. It means acidic character of C2H4 is more than C2H6. acidic character. acidic character का मतलब होता है the hydrogen available for ionization character. acidic character of acetylene. This is acetylene. The C2H4, ethylene, you can say ethylene. So similar type of example of in inorganic, you can see BCl3. BCl3, BH3. These are show the SP2 hybridization. SP2 hybridization. That means triangular planar bond angle 120 degree, near about, but depends upon the some other factors like bond pair repulsion, bond pair and lone pair repulsion, that is called Vesper theory, valence shell electron pair theory, that I will tell you later. Now we discuss SP hybridization. SP hybridization. The three type of, we are here telling you three type of hybridization: SP3, SP2 and SP. Because the carbon atom shows this type of hybridization only. But hybridization are also depend upon the orbit which are participate in the hybridization process. It also a type of SP3D, SP3D2, SP3D3, DSP3, like this way. This is also a type of hybridization found in inorganic compound. So I will discuss this type of hybridization in inorganic chemistry. Here we focus to organic chemistry, where carbon shows sp3, sp2 and sp type of hybridization. So in sp hybridization, as you know, as per definition, 1s and 1p orbitals go under hybridization and form sp hybrid orbitals. sp3 hybrid orbital. So how many orbitals? 2. 1s, 1p. 2 go under. You can write down also. Only 2 orbitals go under hybridization and form 2 numbers of sp hybrid. 2 number orbitals. So just like in sp3, 1s and 3p go under hybridization, in sp2, 1s and 2p goes under hybridization. Similarly in sp hybridization, 1s and 2. So here we see if in C2H2, acetylene, or called ethylene. In ethylene, if you see Carbons behave like this. Carbon in ground state, as you have seen earlier, this is 1s, this is 2s, this is px, py, pz, this is px, py, pz, 2p. There are three orbitals in 2p, along the px, along the py, and along the pz. So this is called px, along py and pz. So pz is empty. This state is called ground state. This is the ground state. There is no bond formation in the ground state. Carbon always, any element before bond formation goes to excited state. After that it forms the bond, but it founds that structure and bond length of the bonds which are involved in the bonding have different energy. So to explain the same pattern of energy of all bonds, same bond length and the shape of the molecule, hybridization come into the existence. Hybridization is a theoretical process, only theoretical aspect. It means hybridization is a theoretical aspect come into the existence to justify the shape and bond length, bond energy of the molecule. So you can write here hybridization is a theoretical aspect which shows the shapes shows or explain, which explain, you can say explain the shapes of the molecule, says bond energy, so many things. So this is very important point. Now here we see carbon in the ground state before bond formation, it goes to excited state. In excited state means one electron or more than one electron are moved from the ground state between original state to higher energy level. What is excited state? Excited state is the position where the electron from the stable orbital or lower orbital to move to higher energy orbital. Here you know, as per above principle, energy of 1s is less than 2s is less than pz. Pz means px, py and pz. So in these orbital 1s, 2s, 2p, energy of pz is higher than py and py higher than px. Similarly, this is increasing energy level. Increasing energy level of orbitals. So what is excited state? Excited state is the state where the electron move from the ground state or lower energy level to higher energy level. So this is energy is low, so this electron move here. So how it moves? It absorbs the energy. And move to higher energy. How much quantity of energy it absorbs? It absorbs energy equal to the difference of 2p and pz. Here you must know about the excited state. Excited state is the, you write down, I will rubbish after. Excited state, you understood. First, what is excited state? So many students are not aware with this term. So excited state is the state where electron move from lower state to higher energy level. So the state the state where the electron or electrons moves from lower energy level to higher energy level. So how it moves? It absorbs the energy. By absorbing the energy, absorbing the energy. So how much quantity the energy absorbed? This electron absorb the energy equal to the difference of these energy levels of orbitals. So how much it absorbs the energy equal to the energy of Pz minus energy of 2s. So this difference of energy it absorbs. So before bond formation, carbon or any atoms before bond formation goes to the excited state, and in excited state it absorbs the energy equal to the difference of energy level from where the electron is moved to whom. So I think you understood the excited state. So before bond formation there is a process of excited state. So you see this is the ground state, then again this is 1s, this is 2s, this electron moves here. So the picture is like this. This is px, py, pz, and this electron moves here. So single electron or unpaired electron. Any atoms form bond to complete its octet, or you can say to pair its electron in the orbitals. So in the form, so here carbon show the 6 unpaired electrons, so it will form 6 bond. The number of electrons which are unpaired is the valency of that atom at this state. So this is called excited state. Excited state. Now this is the state where it is ready to make the bond, but it is found that carbon have different energy. Pz energy higher than 2p. So for equalization of energy or study the shape of the molecule or study the equal energy level of these orbitals, there is a process come into the existence that is called hybridization. So in hybridization, like SP1, 1s and 2p. So this is gone under hybridization. Nearest energy orbitals 1s and px. Here 2s and px go under hybridization and form this is sp hybrid orbital. This is sp hybrid orbital, and two unhybrid orbital like py and pz. This is unhybrid orbital. This is hybrid, this is unhybrid. This is unhybrid orbitals. So this is called hybridization process. Hybrid orbitals are formed, two hybrid orbitals. Now this is ready to form the bond. So let us see in C2H2. I think you understood. This is the ground state. What is the excited state? How the electron move from lower energy to higher energy. And after that, before bond formation, there is one thing more happened, that is called hybridization. This is purely theoretical aspect in which the carbon before bond formation give such type of hybrid orbital. So let us see in the shape form. So what happened in sp2 hybrid orbital? sp2 carbon, 2 hydrogen. So carbon is sp2 hybrid. So this is carbon, this is carbon. There are two hybrid orbitals. One is like this, and another is hybrid orbit form sigma bond you have seen earlier. So this is hybrid orbital, this is hybrid. This is sp hybrid, this is sp hybrid, this also is sp hybrid, and this is sp hybrid. And there are two unhybrid orbitals. This is pz, this is py. You can say this is the py, and this is symmetrical type. This is have single electron. Similarly here, this is the pz, and this is the py. This is symmetrical indication. This electron and this electron. This is the carbon. So these are unhybrid or two. These are unhybrid. These are unhybrid orbitals. Unhybrid. They are unhybrid. And this is hybrid orbital. So here we see one bond electron. This is one electron. sp2 hybrid with sp2 hybrid of other carbon form covalent bond. Here in sp again single bonds. Hydrogen will make bond. There are two hydrogen. One hydrogen make here. Second hydrogen make here. Since hydrogen has one s electron and shape of one is shape of, you have studied in organics, shape of s orbital is spherical. So hydrogen only have spherical one s, so it is hydrogen, so it is spherical orbital. So the spherical hybridized. Now this is the C2S4 bonding completed, but these two carbon have unhybrid orbital. So I have told you a real unhybrid orbital form the pi bond. So pz with pz form the pi bond. Similarly px with px will form the pi bond. So one pi bond and one pi bond. So there are three bonds between the carbon. One sigma, two pi. This is sigma. Hybrid orbit form sigma bond and unhybrid form pi bond. So you write down here what the hybrid orbitals form for sigma bonds and unhybrid orbitals form pi bonds. So if we see the structure of C2S2, it is C triple bond C and H. You write like this. So here there are three bonds of carbon between carbon and carbon. Two are pi. This is pi. This is pi. This is sigma. So between the carbon and carbon atom in ethylene, there are three bonds, two pi, one sigma and sp. This is CH, this is sigma bond, this is sigma bond. So the structure of C2E2 is in orbital form is defined here, and the shape of C2H2 or any alkyne is linear. Shape is linear. Linear means in the same straight way, linear shape, and in linear shape bond angle will be 180 degrees centigrade, 180 degree, and S character 50%. In sp2 S character 50%, P character 50%. So it means 50% S character, 50% P character, linear shape, bond angle 180 degree. So this is the example of sp hybridized orbitals. Like this in inorganic also, so the sp hybridization like BeCl2, this or BH2, this shows the sp hybridization. In H2O, in the same way in H2O, you can see in inorganic, this show the same type of sp3 hybridization. In inorganic, I will tell you in detail the different type of hybridization, but since carbon show only 3 type of hybridization, that is sp1, sp2 and sp3, so here we study only this type of hybridization. One question commonly asked, why ethylene or acetylene is more acidic than ethene. It means C2H2 is more acidic than C2H4. Why? So I have told you earlier, this have in C2H2 sp hybridization, and this has sp2 hybridization. sp2 hybridization. In sp2 sp hybridization, S character 50%, P character 50%, here S character 33%, P character 66%. So you see S character is 50%. I have told you earlier, as S character increases, acidic nature of the molecule increases. It means C2H2 is more acidic than C2H4. That's why, therefore, C2H2 is more acidic than C2H4. What is the mean of more acidic? More acidic means easily replaced hydrogen ion. Acidic nature increase means this implies H ion more easily available in C2H2 with respect to C2H4. It means C2H2 hydrogen, you will see in the next lecture, in acetylene CH sodium reacts and this replace this hydrogen and form CNA. This is the reaction. But in C2H4 sodium does not give any reaction. It means this is more acidic, which is easily replaced. This sodium replaced this hydrogen easily, and this sodium could not replace the hydrogen of C2H4. So this is the more acidic. You understood better, you go through, and if you have any question, you ask me. This is the hybridization process, SP, SP2 and SP3. I think you have gone a deep concept. What is hybridization? What is excited state? What happened before bond formation? So it is enough for today. In the next lecture, I will explain you some other aspects of reaction mechanism like inductive effect, electromagnetic effect, SN1, SN2 mechanism like this. So please follow my channel, share and subscribe, and if you have any problem, you write me. Your comments are awaited. Thank you.